because this is when it'll initiate, doesn't mean that's when repair is needed. So they will assume 6 years of propagation time have reached certain level of damage. So the propagation time will be 14 years, so that's that plus 6. At that stage, propagation has made the concrete looks really ugly, so you'll repair. And you're going to repair that 10% of that area. It's also an assumption that you're not repairing the whole thing, you're only repairing 10% of it. And you have to come back and repair it every 10 years, or you have to come back to a different area in every 10 years. Those are assumptions they're making. Okay? And to be honest, that's a valid assumption. For those who work inside, unless you use very different chemicals and very different method of arresting, you're going to come back to the structure. Okay? So it's an assumption. Yeah. They have to make an assumption. We're assuming that not all areas need repair. Very special structures, for example, in industrial environment might need the whole thing to be repaired. But that's, for a car park, that's extreme. Okay? 10% is sensible. I don't know if the new version of the software allows you to change it. So that means it computes the life cycle cost and projects the cost out of repair alone to be £161 over the lifespan of 75 years. Okay, and the total life cycle cost the software will calculate for you is 57.15. Okay, the best thing to do is open up the software and try it. A lot of information is built within, so even if you don't change anything, you still get an answer, and then you can learn from that. Okay, I think and 3B of your notes pack explain how to use how to do a chloride modeling using Life 365. So if you're stuck, go back to that. So I have made a note for you to use it. Trust me when I say it, it's really not complex. So that's my base case, and then I can add different mixes to it. So the software allows you to add any number of mixes as you want. So base case is my starting mix design. Then I'm going to look at different mix design to see which one works better for me. So here I'm using 15% PFA as the next replacement, which is case number 2. And when you add PFA, what should happen? When you change from Portland cement to a PFA blended cement, what do you expect to happen? No, durability. We're in the durability. Should be good, right? So that means your corrosion initiation times will increase. Okay. Now that's probably for a same water binder ratio or a very similar comparative stuff. Yeah. Yes. That's up to you to decide. You have to enter the cost. So in UK figures, PFA is expensive than Portland cement. You can buy PFA, you blend it. It is expensive than Portland cement because it's processed and given to you. The reason they can give someone cheaper is because of the volume.
They are more educated than us. They know our wedding flyers, life is going to be increasing. But which are not, which Indian of still not able to believe, isn't it? They feel why to have flyers.
But if it's cheaper for you, it's even better.
Yeah.
Like this figure is going to go even more down.
Yeah, in India it is very cheap because the flyers is still available. Only the transportation cost is very.
The problem in the UK is we're running out of fly ash. We haven't had any thermal power plants for long enough. And also the volume of sales is so small that it's not an efficient system to make fly ash and supply to you at cheaper cost. There's only one or two suppliers even now, so, and that's why that's higher price. But you can reduce it. Silica fume will be same cost because it's only 5%. It will result in longer corrosion initiation time. Bear in mind, I did say the software is owned by Silica Fume Association. So, and if you use corrosion inhibitor, you get even a better life. That's the Grace Chemical supplying the information. And if you use stainless steel, which should be considered as an option, you don't have a corrosion initiation time because they don't have the data for it. Very likely the corrosion initiation time will be much, much higher. Okay. Would you consider stainless steel as an option? Do you get stainless steel bars here? Yeah. My answer is yes, you should. Not for every exposure, but for critical exposures, wherever it says 3 or 4, you should consider it stainless steel. There are efficient decouplers available now, so you can have a normal steel bar. There's a decoupler. You put a stainless steel bar for a certain height, if it's a column, put another decoupler and then you go. So it's a very efficient way of adding to it. In critical areas you should consider, because the repair cost will be, I've used the same repair cost here because I don't have a figure, but it won't need much repair. There are different grades of stainless steel, am I right? There are different grades of stainless steel, right? Are you aware of it? There's 316 and 314. There's a 316 anyway, and there's one more grade. Grades of stainless steel. 316 is one of them. I think it's a good one. There's a lower version of it. It is to do with the amount of nitrates, I think, or amount of nitriding. Okay. And chromate. So inclusion in the steel, that makes it to a very shiny stainless steel stuff. The amount of inclusion will say it's grade 1 or grade 2 or grade 3. But in the UK, I think we say grade 316. Okay, there may be one more number to it. It shows the impurities in it, which is making it better. So stainless steel is also a different cost. So just bear that in mind what you're buying. Stainless steel, yeah. I think it should be considered for critical structures, especially if lifespan goes to 75 to 100 years. Really consider it. Very difficult to work on the site though. It's not an easy stuff to work. Don't know. Don't know how effective they will be. Yeah. But most of this, yeah. I don't know if stainless steel fibers are available. I haven't heard of it. The steel fibers have some form of coating in it anyway.
Yeah.
Okay.
While mixing, they go.
Yeah, they'll disappear quickly. Yeah.
Coating goes away.
No, we use stainless steel and polypropylene fibers for areas where we expect problem. Stainless steel bars and polypropylene. Okay. You can add the repair cost. Are you asking how do I get this? So in the software you need to add the repair cost to it. So the software asks you what is the cost per meter square of repair.
Is that from the experience or is that your basis for calculating?
The software knows a cost, but that'll be a US cost. But it's better to ask anybody who's in the business what will be the meter square. So every asset management agency, whether that's PWD, CPW, they have a rate in their database because they call that rate as their base for asking quotations and tenders. So they have the rate. Get their rate.
Repair cost. So what is the breakup of repair cost?
Whatever cost transfer, repair, everything.
The repair cost would be to make good will be to remove, clean the structure, do whatever to make good the same way as you left it. And you can change the cost clearly. If you think the repair should be certain nature, then you can change it. This need to be looked at carefully if you have a perfect surface. So for example, if you have a cladded surface, marble or any other cladded surface, and you decide to repair, they're making good is costly because you have to take everything out, put everything back, and put the cladding back. That might mean expensive business. Otherwise, repair could be just somebody spraying the repair, cleaning it up, and getting out.
It includes the retrofitting also.
Not structural. None of this is structural. It is just repairing the concrete, not retrofitting. Retrofitting in the sense structural retrofitting, or no. Once an area is spoiled, you can't rely on it anymore. It will not, in my view, it won't take any loading. It's just a paint. It's a glorified paint from that point. Okay. You're at the beginning. You're at the beginning of the structure. This is not for existing structures. You can do that for repair, but maybe better to use it your own calculation for repair. But you're now at the specifying business, saying this is the mixes I'm suggesting, which might have a corrosion inhibitor in it, or might use stainless steel or different cement combinations. What I'm saying is you should use this figure, which is the whole life cost, to say if I use CEM1 normal Portland cement, my average meter square cost over 75 years is 57 pounds. If I use any of the other products, it will be lower. But all of this is higher. If you look at it, they are much higher than the initial cost. So I'm educating the client by saying, yes, you're paying 20 now, but remember you're going to pay another 30 by 70 years' time. Do you want to spend the money now or not? Let them take the decision, and they will take the decision based on clearly the availability of funds. If your client is, let's say, a factory and they're in the long run, they might say, we will actually go for this. Because the last thing they want is a failure. Because they're making money by hour, so it doesn't matter to them whether you put it at a higher cost or lower cost. Most of the clients these days are rich, except the governments. So, happy enough? I'll ignore that anyways. In the asset management business of government, they have all of this information in the database in the UK. So this is the structure that is an existing structure, anonymized it anyway, structure A. The capital cost of the structure to make it then was £50,000 nearly. So these are in pounds. So these were the other costs that they had to pay to get the structure to make it in 50,000 or 500,000. So remember the cycle of inception cost, or inception and design and planning, and then delivering to site. So this is the delivering, this is the pre-design costs. Okay. They have another figure to say, if I'm to do that again, what will be the cost? And they know the difference. Okay. It's a mathematical prediction, an accountant's job basically. They will be able to do this. The next thing they do is, what is the quality of the structure? What's the grade? Is it in good condition or is it in bad condition? 1 is the best, 4 is walk away from it. Okay, and that determines the value of the structure, and that also determines how much money they get from the government. They get from the ministry to do the work. So if most of their structures are in 2 and 3, okay, they get less money. If most of their structures are going towards 3 and 4, they do need a lot more money to make good of those structures. And that's the metrics that they use in the UK to ask for money. So all of their structure, whether that's a tiny culvert or a massive structure, they have a grading for it. They have a calculation at the back of it, and that calculation cumulatively tells the minister when they're allocating money to allocate. That's how it works in the UK. I'm glad I anonymized it because the DARDINI identifies what department it is. NI stands for Northern Ireland, by the way. But they have these in thousands. In Northern Ireland, we have 5,800 bridges. That's what we have. Out of the 5,800, a large majority cannot be called a bridge. It's a tiny culvert of 1 meter or 2 meter. They're not a bridge. But a good portion of those 5,800 structures are between 2 and 3. There is a nominal portion between 3 and 4. Some clearly sitting at 4. It will have some form of severe restriction on travel on those bridges. So only cars might be allowed. So when you drive into a bridge, you'll see an example tomorrow. You might see a plate saying 7 tons, 3 tons, line restriction, all of that. So there is a small section of those structures as well. And they have lists for everything. Okay. So if you want to make a list of yourself, then there you go.